combining a lot of little pieces together. And at first I'll realize this is not hard if you do it exactly like I write it on the board. Okay, this would be given to you. This information is the given. And first I went ahead and put what I would ask, but then I have to erase to work it. So I'm just going to put what I'll ask for each part after that. But here would be what's given to you. And then there would be questions like, what is the sign of alpha plus beta? Or alpha minus beta? Let's just go ahead and write that. Like, it might say, what is the sign of alpha minus beta equals question mark? But that up there would be given to you. All right. What you do is under each part, you don't write them one under the other. You don't write this above this, or this under this. You write them side by side on your page. Real important that you write them side by side. And then under each one, you draw your reference triangle, your reference angle. So under this one, you need to go to quadrant 4. And you try to draw a straighter line than that, Evans. Maybe I'm getting old and tired and mean. Quadrant 4. So, come down to quadrant 4. Probably make that a little bit bigger than I needed to. Come down here. Put your 3 here. And your 5. And what I'm hoping you do is you realize that that's not just a 4, that is a what? Negative 4. Is everyone okay with that? That's a negative 4. Now, after you do that, you go over and you draw your other reference triangle. Do not draw them on the same XY axis. It will mess you up. But Mr. Evans, sometimes you do. Yeah. And that's usually when I screw up. Okay, quadrant 3. When I put this in quadrant 3, 24, and gosh, that was drawn to scale. Folks, that's wrong. That's not a 5 there. That's a 7. I think I put it wrong in the last class, too. I think I did. 7, 24, this will be 25. Matter of fact, I know last hour when I taught this problem, I put some up there and acted like it was a triple, and it wasn't. 5, 12, 13 is a triple, right? 5, 12, 13. 7, 24, 25 is another triple. And I'm going to put my beta in here. And someone in here is going to tell me what is wrong. What is wrong? What do I need to add to this?
Negative.
Yeah. These are both what kind of values? Negative. And because remember, tangent is opposite over adjacent. Well, a negative over a negative is going to make a what? A positive. Everybody okay with that? So you got to be real careful to get those negative signs in there. Any question about getting the two triangles drawn? That's what we've already been doing. But if you have a question, I will try to answer it. Anyone? All right. Now, so we ask you, what is the sign of alpha minus beta? You flip over to the back of your unit circle. And on the back of your unit circle, there's a rule for sign of alpha minus beta. And that rule says it is sine alpha cosine beta minus sine beta cosine alpha. And the good news is if you've got the rules and you're allowed to use the rule sheet, this isn't hard. Okay? Makes it pretty nice. So, if I want to know what the sign of alpha minus beta would equal, I've got the rule to use right here. So now look up here. What is the sign of alpha? The sign of alpha is what? Negative 4 over 5. Is everybody okay with that? Okay. What is the cosine of beta? Do you now see where if you'd have left that negative off, life would have been bad right here? Is that okay? Life would have been bad. minus the sine of beta. And what is the sine of beta? Negative 24 over what? 25. And what is the cosine of alpha? And somebody says you could look right here and know what the cosine is too. Yeah, you could. But it's 3/5. Now, once you put the numbers in the blanks, it's algebra. But see if you have any question about getting the numbers in those blanks. Give me a chance. All right. You multiply here, you get 28 over 125. That's going to be negative, be positive 72 over 125. Notice how you got a common denominator. Is everybody okay with that? You got a common denominator. You'll get 100, 12. Can't believe you're getting a nice, perfect number. 28 and 72. You get what? You get 100 over 125. Right? I guess it does, yeah. Sine of beta is negative, cosine of alpha is positive. Yeah, it does. So you get 100 over 125, or you get 4/5. There is the sine. Now, can't believe I got one that worked out that nice. Okay, I'm still looking for where I made my mistake multiplying or dividing or something. But I just can't believe it worked out. But here's the thing that I should point out that's really beautiful. If you work these right, you're always going to have a common denominator right here. Okay? If you work them right, that's always going to be a common denominator. Now, I can look at this and probably already tell you what the cosine is equal to. But I'm going to pretend that we don't know. And I'm not going to take a chance on being wrong. So I'm going to do cosine of alpha minus beta. I want to know what the cosine of alpha minus beta would be. Well, I have to look on my rules. Fair enough. And I find out the rule is cosine alpha, cosine beta, plus sine alpha, sine beta. And I'm pretty certain it's going to be 3/5, but I don't know if it's going to be positive or negative. But let's find out. What's the cosine of alpha? 3/5. What's the cosine of beta? Negative 7 over what? 5. Plus the sine of alpha. Negative 4/5. Sine of beta, negative 24/25. All right. Now, 21 over 125, negative 21 over 125. Somebody says, Mr. Evans, you better be careful. Plus 76, 96 over 125. Somebody says, Mr. Evans, you need to learn to add, multiply. And 96 minus 21 is 75 over 125, and I get what? 3/5. And I didn't know if it would turn out to be a positive or a negative. Okay? But most of the time they don't come out that pretty anyway. I won't do this one next hour because I made it up and it just doesn't look pretty. Is that okay? Now, I'm going to show you something. You realize that if you square the cosine of all that, and you square the sine of all that, and you add them together, you're supposed to get 1, right? Remember the mother identity? 4 squared is 16 over 25. 3/5 squared is 9 over 25. Add them together, you get what?
25.
1.
25.
Yeah, so you get 1. Yeah, you get 1. And that's one of the little checks. You can always know that if you square this one and you square this one, as long as you're doing, now if you're doing A plus B here, would it work? Not if you're doing A minus B over there, it won't. They got to be what? The same. But if you square them and add them together, you'll get 1. And that's what we're going to be looking at today is where you have multiple of these. Now, I'm going to show you a little trick for finding tangent. If you have already worked all of these out, and you want to know what the tangent of alpha minus beta is, just put the sine value over the cosine value. 4/3. All right? Or you can use the formula that I gave you on your sheet. Now remember how I told you I didn't ever use that formula on the sheet and I had to look it up? It's because if I got the sine and cosine, I don't need it. Now, if you're trying to find the tangent and you didn't have the sine or the cosine, then you want to use that formula that's on the back of your sheet. I like it. The back row's awake. Never come. Okay. Now, next step. Okay, before I do that, and I'm not going to talk about the algebra, is everybody okay how I put the numbers in the blanks? Y'all see this isn't that hard if you use the right formula? But you've got to draw the triangles right. If you don't draw the triangles right, that's when we run into trouble. Okay? All right. Now, here's the other place that you can use these formulas. I tell you that I would like to know the sine of 15 degrees. And I want the exact value. I don't want the decimal that your calculator makes up. I want the exact value. And that's how we get around y'all being allowed to use your calculators and put out all those decimals that no one wants to see. Okay? Exact value. So, if you look on your circle, there are probably two values that you could add or subtract on your circle in degrees that'll give you 15. What are they?
45 and 30.
45 and 30. So what I'm going to do is I'm going to make that sine 45 degrees minus 30. Alpha minus what? Beta. So this gives you the opportunity that any two values that you can add or subtract on your unit circle, you can find any of those combinations of trig function values too. Yeah, the values we started with, you could eventually find hundreds of values around the unit circle by simply using these formulas. Okay, so it's going to be sine, and I'm going to write the rule down first. Sine of alpha, cosine of beta, minus sine of beta, cosine of alpha. I'm just showing you the rule I'm using, right? Everybody okay with that? So it's going to be what? Sine of 45, cosine of 30, minus sine of 30, cosine of what? 45. Well, the sine of 45 degrees, I know it's on my unit circle, right? Is that okay? So 1 over the square root of 2. Then I'm going to do the cosine of 30. How much is the cosine of 30? Someone tell me. What's cosine of 30? Square root of 3 over 2. Minus. Excuse me. What's the sine of 30? What's the cosine of 45? Now, notice, the great moment here is that you get a common denominator. See, they're already common. If you work it right, they'll always work out with a common denominator. Somebody says, Mr. Evans, that's not the answer in the back of the book. Okay. That's the answer in the back of the book. What they do to that, they rationalized it. Multiply the numerator by square root of 2, multiply the denominator by square root of 2. Okay? And that would be the sine of 15. That's the sine of 15. All right. You notice I didn't give you any rules for cosecant or secant, did I? Because you do realize that the cosecant of 15 degrees is equal to 2 square root of 2 over square root of 3 minus 1. Because cosecant is simply the what? Reciprocal of sine. That's the reason you don't need a cosecant rule, a secant rule, or a cotangent rule. It's because if you can figure out sine, cosine, and tangent, you just take reciprocals and you got the other ones. And there's your cosecant. Somebody says, would you have to rationalize this? Yeah. And you got to multiply by the conjugate and all that. I don't rationalize. All right. Now, I'm going to teach you a few more trig identities to throw in here today. And these need to go on the back of your circle, and I'm not sure where you want to put them on the back, but these are some more trig identities. I'll just throw these out there for you for a few minutes. These are some little special trig identities that I forget to give you, and I'm trying to remember today. All right. And to do it, I'm just going to look. You know, that's positive thetas, right? And that's negative thetas. This is going in the negative direction on the circle, and that's going in the positive direction. Fair enough? Okay. The first rule, and sometimes I tell students if you have room, put these at the bottom, because these are real handy. The cosine of a theta, an angle that's positive, is equal to the same thing as the cosine of the negative of that angle. That way you never have to work with a negative angle. In other words, if I start a problem and I see cosine negative pi over 3, that's equal to cosine of pi over 3. I don't have to deal with the negative. It's not true for any of them except cosine. But it's a cool little trick. Well, if you're in a calculus class and you have to take the derivative of cosine negative theta, first thing you do is change the cosine positive, then take the derivative. That way you don't have to fool with that what? Negative. You'll see students in a calculus class, they'll walk up to you and go, my answer was cosine negative 3. Okay? That's what they got. But they look at the back of the book, and the book just has cosine 3. Because the book used this identity and didn't use that negative sign. Fair enough? That's true for cosine. Now, and if you look on your circle, you can see it pretty quick. If you go to right here, that is 1/2 comma square root of 3 over 2 at pi over 3. And down here at negative pi over 3, you're at 1/2 comma negative square root of 3 over 2. Is that okay? So it works. The second rule is the sine of negative theta equals the same thing as the negative of a sine of a positive theta. I really wrote that rule backwards when I wrote that. I should have put the negative over there. But the sine of a negative theta equals the negative of sine theta. You are not factoring that negative sign out front. You are not factoring it out front. If you were factoring it out front, then you'd have to do it there. And it doesn't work that way. Okay? But if you have the sine of a negative pi over 6, what I'm going to do is I'm going to do negative sine of a what? Positive pi over 6. And look, it works. Do pi over 3. There's the sine, and if you do negative pi over 3, look what happens. You get what? You get a negative. So these are two rules that help you not have to deal with the cosine of a negative number or the sine of a negative number. That's what they avoid. Is you don't ever have to worry about sines of negatives and cosines of negatives if you have these two identities written on the back of your circle somewhere or at the bottom on the front, because you use these a lot in calculus. Good deal? Very handy. Now, I'm going to go ahead and write two down that I want you to put on the back of your circle so I don't forget them. And they're using a thing called integral calculus. Yeah, that's a little sign that looks like this, like that. Okay? That's an integral sign in calculus. All right? I don't. It looks like the little violin opening. You know, just the opening you see in violins. That's what it looks like. Okay? But that's an integral sign. But in integral calculus, there's two identities that you use all the time. Sine squared theta equals 1/2 1 minus cosine 2 theta. 1/2, 1, and all in parentheses. You'll never use that identity anywhere else. That's the only place it's used is integral calculus. It's one of those identities that they have in the book probably, but honestly, there's only one place that you ever really use them a whole lot, and that's integral calculus. And there's the one for cosine squared theta. And what will happen is when you're in calculus 2, this can be at the very end of calc 1. Let's be honest, this is usually in calc 2, beginning of calc 2. Beginning of calc 2, your professor will be on the board and he'll write the integral cosine squared theta d theta. And then the next step he writes this. And you are sitting there in a class of 200 students wondering, where did that come from? And you don't want to raise your hand and ask him because he's going to look at you and go, it's an identity. That's it. That's the identity he's using. Okay? But it'll be for this integral calculus stuff. And so on the back of your circle, put a little, the little integral calculus symbol and then write those two down because that's when you're going to use them. All right? And yeah, go ahead. And so the deal is, I'm just trying to give you a heads up that there's more identities than we're going to use in this class. That's two of them you're going to need later on. These two you can use in this class or a lot of classes to make things easier. All right. Leave those over there for a second. Now, there's a whole list of identities for physics. And I don't know them. I'm going to give them to you and let you put them on the back of your sheet later this year. But I want to show you what they are, and I'll show you why I don't know them. All right? There's an identity for what happens if you have the cosine of 180 degrees plus some angle. In other words, what happens if you want to add 180 degrees to your angle and you want to know what the cosine is? In other words, if you knew what the cosine of 15 was, what's the cosine of 195? Does that make sense? In other words, what changes about the cosine when you add 180 degrees? All right. Well, the reason Mr. Evans doesn't remember those from physics is because he knows A plus what? B, right? So what I do is I go, okay, cosine of 180, cosine of theta, minus sine of 180, cosine minus sine theta. Evan's brain quit working. Okay, I use the rules. Cosine A plus B is sine A. Cosine A plus B is cosine A, cosine B, minus sine A, sine B. And the good news is, I know what the cosine of 180 is. What's the cosine of 180? What's the cosine of 180? -1. So I get negative cosine of theta. And then what's the sine of 180? Sine of 180 is 0. Negative cosine theta. So if I take and I add 180 degrees to an angle, it equals the same thing as the negative of the cosine of that angle. Is that all right? And what they do in physics is they have a whole list of these for adding and subtracting 90 degrees and 180 degrees. All right? Because when they're dealing with vectors, you have a vector here, and then you have a vector that's perpendicular to it, so that's 90 degrees. But they got, and see, and what your physics teacher is going to tell you is cosine of 180 plus theta equals negative cosine of theta. All right? And there's a whole list of them. I'm going to put them on the back of the circle eventually, and I'll probably derive a few of them, but if you know the A plus B and the A minus B rules, you can figure any of these out that they give you.